Hi, everyone. Welcome to today's Developing Secure Systems Summit talk. My name is Michael Hicks. I'm the moderator for today, and I'm very pleased to introduce today's speaker, Ashley Williams. She is the Interim Executive Director of the Rust Foundation. The Rust Foundation officially emerged in February 2021 after Mozilla, the original owner and developer of Rust, decided to step aside from those roles. Ashley has long ties to the Rust community and is a member of the Rust core team, and she's participated and led various teams in the Rust project, from crates.io to community to WebAssembly. And she's previously worked as an engineer at Mozilla and PM and Cloudflare, and served as a member of the Node.js board of directors. And today she'll be speaking more about Rust and about what it offers to secure program development and how the Rust Foundation aims to help it thrive. Ashley.
Fantastic. Can everybody hear me? All right, awesome. I was going to say Teams is not showing me my own video, so I hope everybody can see. I'm really excited to be here today, and as somebody who is talking about Rust at a thing called Developing Secure Systems, my topic today is going to be safety. I could probably give a whole talk about the difference between security and safety, but for this talk, we're going to put that aside. Yeah, I'm really excited to be here. So as Mike said, my name is Ashley Williams. I'm also known as AG Dubs on the internet. If you follow me on Twitter, I'm sorry. I have been a member of the Rust core team for the past 3 years and have been participating in Rust for a long time. And I decided as my global pandemic coping strategy, I was going to speed run spinning up a nonprofit organization with some other folks on the Rust core team, which ended up turning into the Rust Foundation, which I'm incredibly excited about. So my goals today are to introduce a little bit of Rust. It's very difficult to know what the background of the audience for this talk is. So there's a chance that some of you all may already know some of the topics I'll introduce about Rust, but I hope that there is a portion of this talk at least that you will find particularly interesting. So to start, what can we say about Rust? What is Rust? So Rust is a programming language, and on its website it says that it is a language empowering everyone to build reliable and efficient software. And so we really love that slogan, and one of our favorite words in that is the word empower, which I will get to in a little bit. But why would there be a talk at Developing Secure Systems about Rust? And this is because ultimately, we will say Rust is safe. Rust is a safe language. And today we're going to talk about what exactly that means. So it may surprise some people in the audience to know that my background is not actually in computer science. My first career, I was a middle school science teacher in Harlem, and my degree is in philosophy and neuroscience. So any Ashley Williams talk is going to get a little philosophical, where I'm going to ask, what does safety mean? But what I can say is, at least for this talk, this is, again, probably you could do a whole seminar on what the concept of safety means, even just in the realm of technology. But for today's purposes, we're going to talk about 3 types of safety. We're going to talk about safety at the language level, safety at the developer level, and then safety at the organization level. And so if you are potentially surprised by the number here of safety elements, this talk is for you, and I'm really excited about it. But to start with, probably on the face of it, what everyone is expecting to hear today is, what does safety mean at the language level? It looks like my slides are not changing. There we go. What does safety mean at the language level? So when we say that Rust is a safe programming language, we are saying that Rust is memory safe. So if we were all together in a room, I'd probably ask some folks to raise their hands, and I would say, how many C or C++ developers are in the audience today? And then I would probably go through a couple of other programming languages to kind of get a sense of where folks are coming from. Because for some folks coming from certain areas of programming, there's not always a complete understanding of what memory safety even is. And this was actually a bit of an identity crisis that the Rust programming language had early on. So folks who have been part of Rust for a very long time may remember Rust's original slogan, which was Rust is a systems programming language that runs blazingly fast, prevents seg faults, and guarantees thread safety. And the original pitch for Rust was that Rust is memory safe. But a lot of folks didn't fully understand what memory safety meant, and that was often because they were coming from garbage collected languages. And we'll talk about that in a second. So what is Rust's take on memory safety? So in the Rust world, we usually like to say that the safest program is one that doesn't compile, ancient Rust proverb. And so the idea here is that in order for your program to be run at all in a compiled language, the Rust needs to the program needs to be compiled. And so we want to introduce safety at the level of compilation, which is to say, if the compiler decides that your program is not safe, it just simply will not make your program. And if it won't make your program, you can't run it. And in this sense, it is the safest program. And this is really important because many folks have done research that demonstrates this. This is a link to something from the Chromium project, though I think the original research may have been done by Mozilla, that 70% of security issues are memory safety bugs. And when we talk about memory safety, we're talking about, use after free, buffer overflows, and here these safety bugs tend to be things that are not intentional, but ultimately become exploited by folks who are finding them in a way that is intentional. And so a lot of security vulnerabilities end up being the exploitation of accidental safety bugs that have to do with people manually managing memory in a way that is faulty. So there's a classic trade-off in programming language design around memory safety, and it tends to be this question, which is either you can have garbage collection, or you're going to require that folks need to manually manage their memory. And as you may suspect, this manual management of memory tends to cause issues because humans are imperfect, of course. And so this is a theme that has existed throughout Rust, but often when proposed with some type of dichotomy, Rust goes, what if there was a third way? What if we don't have to make this choice? What if we can do something different? And the concept that Rust introduces here is the concept of ownership. And so this says, hey, you can have memory safety, but you don't have to manually manage your memory yourself, and you don't have to have garbage collection. And so here's how you might do that. So these are some very, very simple examples to hopefully demonstrate it. People take classes. There's a notorious learning curve about understanding these concepts. So this will be just a brief introduction to them. But let's say if we look up at the code at the top here, we have let s1, defining a variable and assigning it to a new string, hello. And then what we do is we create another variable and assign it to that value of the string. And then we attempt to print out that value in a templated string here to say hello world. And while code that does something like this might potentially compile in other programming languages, in Rust, you would get an error. And so here's an example of a Rust compiler error. And what the compiler is telling us is, hey, you're trying to borrow a moved value. And so what's happening here is we set up that original value or variable, we assign it to the value, and then when we assign that value to the new variable, we move it. And so that means when we attempt to use it again later, it's not there. And so as a result, the compiler says, hey, this is not memory safe. You're going to need to fix your code. And so if you wanted a bit of a picture about how this is kind of laid out in memory, we have the S1 here, and then that memory gets invalidated when that gets reassigned to S2. And so this is a kind of a very simple introduction to the concept of ownership. All right, so in addition to ownership, we have the concepts of references and borrowing. We actually already saw that term borrow in the compiler error on the slide before. And so what this means here is that we may not always want to move a value. We may just want to be able to reference it. And when we reference it, we can borrow the value and use it, but Rust won't let you change it. And so here's another example of this where we have a main function, we have another variable s, we assign it to this string hello, and then we try and pass it to this function change. Now you'll see here this ampersand, and the ampersand is representing passing something by reference. What that means is, hey, I still own this value, but you can borrow it here. And it's kind of like lending a book to a friend, right? And when you lend your book to a friend, when they give it back, you expect it to be the same book. And you'd probably be pretty upset if they decided to rip out a bunch of pages and maybe like add some drawings in the margins, right? And so here, what's happening is we're passing something by reference and then we're attempting to change it. And the Rust compiler is going to go, hey, you can't do that. And so you can see here we're taking something by reference. It is immutable by default. And so by attempting to borrow something as mutable without explicitly defining it, the compiler is saying, hey, you are managing your memory here pretty poorly. We're going to need you to write this code slightly differently. And so that's the kind of concept of references and borrowing. And so there's a lot of things that get into this. This is notoriously something that people often find to be the most difficult part of learning Rust, is kind of wrapping your head around this. But that's also kind of exciting because what this does is it eliminates a extremely large class of bugs that you would otherwise find in code that is written at this level. And it does it at the compiler level for you. So one of the biggest concepts in Rust is this idea of zero cost abstractions. And it's directly related to how Rust is solving this memory management issue. So when we talk about garbage collection or manual memory management, one of the biggest things that we're dealing with here is this question of safety or power, right? Garbage collection means that we're safe. We have memory safety, but we want the power of manual memory management. And so when we say that Rust is memory safe, this is something that people often say. One thing that's kind of unique is that, you know, Ruby is also memory safe, but that's not usually something of note. People are not like writing articles about the memory safety of something like Ruby. It's memory safe because it has garbage collection. Rust is memory safe because of this interesting concept of ownership, references, and borrowing. So Rust has this really great combination of safety and power. And the great thing about this is that it is introducing this memory safety as a cost during the compilation process, not as a runtime cost. Whereas garbage collection, this memory safety comes at a runtime cost, which can often lead to, you know, performance issues that folks are not super happy about. So we're able to manage balancing this safety and power by putting the element of, like, you could almost consider it like compile time garbage collection, but I mean, don't say that. Just saying those words probably made a lot of people really upset right now. But it is a type of way of thinking about moving that cost of memory safety to a new spot. And so this combination of safety and power is really the thing that makes Rust, which is really exciting. And this combination we often like to call hack without fear. And so what this does imply is the idea that if you're using a language that has manual memory management, because of the threat of these bugs, the threat of your humanity, the fact that you are an imperfect being, can be the cause for fear. Whereas by offloading that work from you as an individual programmer to your tools, to your compiler, you're able to feel significantly more empowered to write the programs that you want to write, knowing that you can avoid this class of bugs that would otherwise cause serious problems in your program. And I really loved this slogan, and Rust has always had these kind of moments of revisiting and thinking about its slogan. And one of my favorite ones is, this is me making a pull request to the Rust website when we were originally kind of redoing it. And my subtitle was "The Programming Language That Empowers Everyone to Become a Systems Programmer." And so in the last RustConf keynote that I gave last year, I kind of expanded on that a little bit, which is to say, by introducing these new concepts and introducing the idea of memory safety as a compile time cost, not as a runtime cost, Rust is doing something particularly special, I think. And so the slogan that I like to use for Rust, my kind of personal one when I'm pitching it, is that Rust is the programming language that empowers everyone to be a systems programmer, especially people who never thought they could be. And so as we kind of move away from this idea of language level concepts of safety, thinking about what Rust means for the ecosystem of developers, I think is really important. So some of you may know Bork on Twitter, also known as Julia Childs. She writes a lot of fantastic zines about all different types of system programming concepts. And she wrote one about Rust, and I was particularly drawn to these two sketches, where the first one here says, "Rust makes improbable programs possible." And this is not just, you know, a sketch. Rust was originally conceived of at Mozilla in their efforts to rewrite some elements of Firefox. There was a deep desire to parallelize processing that's done in certain engines in the browser, and attempts to do so in C++ were just consistently failing, to the point where it was actually conceivable, like, wow, maybe we should write a new language to solve this, which is a pretty drastic measure. And it ended up being successful, and it was due to the fact that you're able to hand off so much of the cognitive overhead of a lot of the things that you would otherwise expect a systems programmer to do to your tools, which allows you to really focus on what you want to build. And so this second sketch here, which I think is really fantastic, is that ultimately at the core of Rust safety is this concept of empowering, which is this idea that with Rust as your tool, you can finally say, hey, maybe I can write that program and I could do it. Whereas otherwise with previous tools, a lot of these things were really quite difficult. And so one of the most exciting things about Rust for me is the idea that systems programming as a discipline is now more accessible. It is accessible to more people. Literally more humans can do systems programming now because Rust is available as a tool. And the memory safety elements of this are not the only thing. And so just as a quick aside, I'd also share, this is a quote from that same keynote from Nico Matsakis, who is a colleague of mine on the Rust core team and has done quite a bit for the language design and is the lead of our language team. He wrote, "Nice things, not just for JavaScript developers anymore." And in before anybody thinks this is a dig at JavaScript developers, it absolutely isn't. For some reason, there's a culture in systems programming that it has to be hard and it has to feel hard, it feels like. And so just to give a quick shout out to some of the other things beyond this kind of like handling memory safety for you that Rust offers you over potentially other systems programming languages. First-class package management. We have a Crates.io package registry. We have Cargo, which is our unified build tool, which also includes doc generation, test runner, a linter, code formatter. There's a bunch of stuff in there. We have absolutely fantastic error messages. We care about our documentation. We've run efforts across the language called the ergonomics initiative. And there's really just so much more. And we personally feel that this is incredibly important because part of the the safety and the power of the Rust programming language comes from its community of contributors and them also feeling safe. So when we when we talk about Rust and Rust being empowering, like, Rust ultimately means that there will be more systems programmers. And if that is not a type of safety for the industry, I really don't know what is. The idea that systems programming was relegated to a select few magicians who could define magical properties of silicon chips, it doesn't need to be the case. And as I think about where systems programming can go in the future, having more people from more diverse backgrounds at that table is going to be what makes us achieve that future. And so this idea of being able to hack without fear, I think, is really important. Now, there's something also here in this idea of hack without fear. Of course, there could be the fear of memory safety issues, but as I've already kind of referenced, the systems programming community and the programming community at large is not always the most welcoming thing. And so one of the key safety features of Rust that I think helps really develop Rust as a key technical project is Rust community standards and our code of conduct. We have had one since the beginning. This is a note on Reddit from the original author of Rust, Graydon Hoare, where, and I just want to read this because I do think it is actually quite meaningful, where he wrote, "Well, I wrote the initial code of conduct and put the 'we will exclude you from interaction' phrase in there, so maybe I'll mention the impetus and meaning. I was given the opportunity to start a project by my employer, Mozilla Corp. I had the experience of working, both professionally and on volunteer time, with many PL communities in the past. Communities that were prone to several norms of discourse that I found extremely difficult to deal with, that would have prevented me and several people I knew and wanted to work with from bothering to work on a language at all. In other words, I would not have built the language nor participated in a project of building the language if I had to subject myself to the kind of discourse normally surrounding language building communities. In other words, the norms of other communities were already excluding me." And as it will be a theme throughout this presentation, Rust is the sum of the folks who build it, and making sure that those people can be at the table is incredibly important. And so I would be remiss to not mention this code of conduct and the fact that this code of conduct has technical implications for the future and growth of the project, not simply social ones, as many people often like to critique. So I would call this safety at the developer level. And this is an incredibly important part of Rust's story about safety. So I had showed you a couple of error messages, and I would be remiss if I didn't highlight at least one human who is behind that. So this is Esteban Kuber, who currently works at AWS, and he is one of the amazing humans that works on the compiler error messages. I'd love to highlight him, but what I really want to highlight are two things from his Twitter profile that you can see here. So these two comments, I think, really espouse the ideology behind how Rust thinks about compiler development, and really kind of underscores what we mean by safety and empowerment. So this top display image says there are no bad programmers, only insufficiently advanced compilers, which is to say, as a former teacher, there's always this statement like, don't blame the student. And I think too often when we're developing technical tools, we like to blame our users. But here it's clearly like we should not blame our users. We just need to make our tools better. And then finally, in the description here, we see we spent decades trying to invent a sufficiently smart compiler when we should have been inventing a sufficiently empathetic one, which is, I think, very interesting in that we write tools not to serve some type of like theoretical or scientific purity, but rather to be inordinately and incredibly useful to our users who are trying to achieve a goal. And this type of service attitude to the really amazing technical developments that we've been able to do in Rust is what has really led to this kind of like marriage of both like incredible academic research, but also incredibly practical application, which is, I think, what has been able to take the safety that Rust has at the language level and really make it have a huge impact. So when I talk about this idea of empowerment, I genuinely believe that it is a type of safety in the language. Empowerment is a strategy that rejects scarcity. There's two concepts in Rust community that I think are incredibly important. One is the idea that most things are not net zero, and that we genuinely believe in pluralism, which is to say the more people at the table, the better. And my success does not mean failure for you, that my success can also mean your success. And despite potentially them sounding somewhat classic kind of coming out of my mouth right now, these are overwhelmingly rare as community values in many technical communities that I've run into. And so this type of empowerment, I think, is a critical thing for safety. And part of this is because there's a very classic kind of saying, if you've ever been on a construction site, perhaps you saw a sign, safety is everyone's job. I know when I was at Cloudflare, I was doing an onboarding and they're like, how many people are on the safety and security team? And people are like, I don't know, like 2, 3. And they were like, no, it's everybody at the company. But a key thing behind making safety everybody's job is making sure that it is possible for everybody to do the job of safety. And so that work is a lot of work that Rust has been focusing on. And so as you think about developing secure systems, trying to figure out, are we unnecessarily gatekeeping from people from the work of doing things that make things secure and safe? Because that genuinely may be your biggest problem. And so again, I had fun Googling for images of these things last night, but of course here, memory safety is Rust's job. But to leave us on this idea of development for a second, when Rust was going through this kind of moment around the Rust Edition 2018, we were thinking a lot about what Rust means. And there was this huge discussion, we call it the fire flower moment. And this comes from a quote from Kathy Sierra that is kind of visualized here in this image, where we see a Mario and underneath it, it says a person who is your potential customer, your potential user. And then you see a picture of a fire flower and it says your product. And there's an arrow here that says this isn't what your business makes. And I think too often in technical communities, we believe that the code we write, the Rusty compiler, for example, is what our business makes. And Rust has shifted its perspective here. And said, what we do produce a compiler, but the thing that Rust makes is empowered developers. And here you can see the Fire Mario, and this image is claiming, hey, you think you are a fire flower factory, but what you really are is a Fire Mario factory. And so focusing on not just the tools that you're building, but understanding that the real thing that you ship is people using those tools effectively. I think is really, really critical, and what has, I think, truly made Rust an incredibly successful project. So to kind of round this out, I am here speaking today as the interim executive director of the Rust Foundation. And I've talked to you a little bit about safety within the project, safety within the language, and I want to introduce this concept of safety at the organization level as my final sales pitch to you about the Rust Foundation. Then we can hop into hopefully a bunch of questions. I've already seen some hands up and I'm really excited. The school teacher in me really, really wants you to ask me tons of questions. I love questions. So I classically, whenever I set up presentations, I explode my brain out on Twitter about ideas I had. And so I very anxiously ended up tweeting what ended up being a viral tweet where I was using this kind of classic meme format with you sobbing, you can't just call everything a supply chain attack surface, and me pointing at completely uncompensated open source later supply chain attack surface. So supply chain attacks are I feel like everybody's talking about them right now. I think they are talking about them rightfully so. And I think as we think about what are elements of our supply chain when we are building systems, we can often have a very narrow concept of them. And so what I was really hoping to call out here is that we need to consider labor to be part of our supply chain. And in particular, how labor is handled in the current open source economy is something that I think is an opportunity for growth. So as we were setting up the Russ Foundation, one of the key things for us was that we wanted to create an organization that supports our maintainers. And so this is a slide from the first board meeting we hosted. This is the second slide of my presentation, and it was, whenever we are making decisions, we need to be asking ourselves, how does this help the maintainers of Rust? And this is because ultimately I believe that Rust is what it is because of its maintainers. And this comes from an interesting dichotomy that I'll be completely upfront, I have just completely invented, which is this distinction between what I call a maintainer and what we call a contributor. And I know that many people actually use these words interchangeably, but it is my hope that I can make types of labor and costs more visible by creating this semantic distinction. So when I think about what is a maintainer and what is a contributor, the relationship is that maintainers make contributors possible. So a classic way that you might see that is that a contributor makes a pull request, and a maintainer is who reviews and merges a pull request. So if you're just starting off with a new open source library, potentially, these two roles may be roles that are played by a single person, but as a project scales, inevitably you have separation of roles and tasks, and these become two different classes of people participating inside of a project. And so in general, for the Rust project, Rust team members are maintainers. While it is also absolutely the case that lots of Rust team members make pull requests, their primary responsibility is enabling others to be able to have conversations about RFCs, do design process, and also to be able to submit code. And Rust is actually quite unique in the size of its team of maintainers. We are an incredibly distributed and delegated project. We have 10 top-level teams, 54 project groups, and over 260 active members that I would count as this maintainer level class. And it's important to note that these teams and these maintainers in the Rust project are delegated decision-making power. I am a member of the core team and can say that it is by design and a true success that the number of decisions that we make as a team is actually incredibly low. We are kind of like a meta maintainer in that we help enable the maintainers and the maintainers help enable the contributors. And this is really important because Rust has a ton of folks contributing to it. We've had around 5,500 all-time contributors, and we average somewhere around 350 contributors per release. So not only have we had a lot of contributors, but this number of contributors is rapidly growing. And then additionally, we've had a lot of new folks contributing to Rust, but we've also had a lot of new folks contributing to conversation around Rust. So these numbers are incredibly large. Is really what I want you to understand, is like big numbers are big. And the ones that I think are probably the most big are this idea. So Rust makes its decisions around basically anything that you might call design work of relatively high impact in a transparent process that we call RFCs, or requests for comments. To date, we've had 471 RFCs merged. And I think most fascinatingly, of those merged RFCs, we've had more than 1,100 people participate in them. If you think for a second about just how decisions are made at your company and what it means to add a couple more people to that meeting, for Rust's lifetime, we've had 1,100 people in the design meeting for Rust, and getting all of those folks coordinated and cooperating and collaborating takes an epic amount of work. So a couple weeks ago, I drew this graph on a note card by my desk. Everybody focused on my completely awesome keyboard up there. But if you can, for a second, divert your attention to this graph below. And this is like a general sense of how I see humans move over time. In an open source project. We've got 4 lines here: commenters, users, contributors, and maintainers. And despite how incredibly important maintainer work is for enabling contributors and producing a product, over time we tend to see that number go down. And that tends to be actually around the time that we see users and commenters go up. And that's pretty concerning. And this graph keeps me up at night. And when I think about safety in the Rust project, this feels like a threat to it. And I am very focused on thinking about how to solve this problem, particularly with the Rust Foundation. So when you think about maintainer work often requires high context and incredibly high consistency. And ancient open source proverb, which is, if you have the misfortune to succeed, maintainership is a full-time job. And too often it is a full-time job that pays 0. It is a full-time volunteer job. And in particular, the more participatory your project is, the more maintenance work you need to enable it. The more empowering a project is, the more maintenance required. And the higher quality contributor experience, the more maintenance is required. So this is truly a full-time job, and I would argue that Rust is playing on hard mode, as Rust is wont to do. But again, with kind of classic trade-offs, right? Rust is kind of asking, hey, is there a third way? So if we return to this original tweet about supply chain attack surface, when we look at the set of folks who have incredible decision-making power in driving not only Rust, but also all of the other open source projects that you may depend on, the fact that they are often completely uncompensated for their work is a massive safety concern. Perhaps not as recognized, at least, as memory safety concerns are today, but it's one that I'd really like to flag for this audience as something that we could think about. I know we are a group of technologists right now, but I deeply believe that technology is both political and, as a result, focusing on the economic models are really important. And so my big assertion here is that one of the biggest supply chain security threats to any system at the moment is the current failed open source economic model. And I'm really excited about trying to think about new models to fix that. And so quickly, I would just say, I think too often we have sold the value of open source to businesses by its incredible low cost, the idea that it is free to use. Which I think is just ultimately false. I think the real value of open source is the freedom to collaborate, and that actually is an incredibly expensive one. So as you know, there's this kind of definition of the 4 essential freedoms of free software, and I don't necessarily disagree with these, but I think that they miss the forest a bit for the trees. I think the amount of talent and energy we've seen in the open source ecosystem actually comes from the desire to work together on something than any of these potentially. So again, this idea of freedom to collaborate is something that I think that we're really pushing forward in the Rust project. But what's interesting about this is that collaboration is also just incredibly expensive. And so a very large threat to safety is actually ignoring or underpaying costs. Often there's some type of cost that you don't know that you should be paying. And by either ignoring it or not being aware of it, it can cause a threat to safety. And so this cost of collaboration is something that I'm particularly zeroed in on as I work with the Rust Foundation to think about how we can better not only sustain the Rust project, but also help it prosper. And so one of these graphs that I've drawn here is kind of zooming in on the last one, where we have this kind of corporate users line. And I would say at the moment we're seeing this with the Rust project. And I think this is really, really awesome. Rust is a language that always wanted to be used, and it couldn't be more exciting that it is being used today. But there's work to be done about this huge growth and adoption. And so in a classic way, we see a lot of projects end up where corporate users will often hire developers from that open source project. They'll hire your open source maintainers to now work at their company on a product with the technology. And so this is transferring a certain amount of your people power from your project to working with your product, not working on it. And I often call this the adoption brain drain. And this is something I'm kind of zeroed in on trying to fix. And so it's that kind of inflection point right there. How can we change that inflection point? So a lot of open source foundations focus on growing adoption. And what I really think we need to focus on is this idea of not only just surviving adoption, but capturing adoption, which is to say, if we zoom back out on this piece, this little graph I drew, like how can we align these graphs so that we're not having some of this negative correlation that we were seeing before? So my proposition is that being a maintainer should be a career opportunity. And today it's not really, but what if we could set up systems of affordances to change that? So this is now a small sales pitch where I talk about the Rust Foundation and how you can become a member. But one of my favorite things about how we've set up membership in the Rust Foundation is that we have these discounts, or what I call coupons. And this top one here is the one that I think is the most important, which is to say, for every full-time employee that you have that is a member of the Rust teams, that in their capacity of their job is allowed to work full-time on the Rust project, you get a large discount on your membership fees. And it's our goal to try and incentivize folks to develop open source Rust teams at their organization, because I believe a federation of these open source teams where maintainers no longer have to worry about the fact that living costs money and that all this work they do, they receive no compensation for, that it can be valued and they can receive a salary for doing this work, especially given the amount of value that's derived from the work they do. So we have all our membership levels, but to just quickly say, we've had incredible success already doing this fundraising. And I know within many of these companies, they are focused on generating these open source teams. And this is our current board. And then finally, just for folks, one of the cool things about our board, why is my slide not changing? There we go. Is that we have a lot of project representation on our board, because we do genuinely see the board as a collaboration between our member companies and project members. So ultimately, though, if we can think of anything, as we think about safety from an organization perspective in the open source ecosystem, trying to come up with ways that we can align these correlations is something that's really important. And maybe you are thinking of me right now as this. I actually kind of aspired to this aesthetic when I was in college. I actually had like pieces of paper taped to my wall with yarn. But I do think that ultimately, when we think about systems and systems programming, a lot of the concepts that we think about on the technical level also can apply to the people level. And so I often talk about people systems programming as something that we're really passionate about over here in Rust land. So as a summary, Rust is safe. But when we ask ourselves, what does safety mean in Rust, you can understand our methods to be a defense in depth strategy, which is to say we do enforce safety at the language level, but we also enforce safety at the developer level. And we're starting to embark on what it could possibly mean to tackle safety at the organization level. And this is ultimately because we genuinely believe that Rust is the emergent product of the people building Rust. And I think that that's really important. Like what Rust is the collaboration of the folks who are building it. And so the power and safety of Rust is going to be directly related to the power and safety of those people building it. Secure people build secure systems, right? So collaboration is absolutely super expensive, and people are expensive, but they are worth it. So when we talk about investing in Rust, it means investing in its people. And so if you are someone who is passionate about secure systems, which I would assume you are as you have showed up today, when you think about investing in safety, it can be too easy to pigeonhole that to technical solutions. And I would encourage you to think about investing in safety as also investing in people. Thanks very much. Let's take questions.
Thank you very much for that excellent talk, Ashley. I really enjoyed that. So for all of those listening, please, we have two modalities for questions. One is you can raise your hand using the Microsoft Teams feature, and the support folks who are making this presentation happen will unmute you, so you can ask your question that way. Or you can do what Rance just did and type your question into the chat, and then I will relay it. If you're watching on YouTube, you can likewise type your question into the YouTube chat, and Nick is monitoring that and will get it to me, and I will relay the question. Okay, so first question from Rance Cleveland. How do you envision interacting with standards bodies like ANSI or ISO? And here I'm thinking about standardization that has helped the sustainability of C and C++ communities, for example.
I should have known that the first question would be about like standards or specification. This is a really big topic in Rust right now. So I think there's certainly a couple of things here. I think the first thing that I would share is that the rules of collaboration in standards bodies in general are kind of anathema to how rules of collaboration work in Rust. So I don't think that those rules are necessarily like, they don't have a causal relationship to standardization. And we have been talking about having a specification for Rust forever, and the conversations are only picking up steam. But when we think about if we would participate with a standards body, I think we'd have to really look at how we could align the process of developing a specification with Rust collaboration values. So standardization, specification, there's also qualification. There's a lot of things in this area that I think Rust absolutely does value. But making sure that we can preserve the values of our collaboration model in that process is really critical.
Great. I have a question, actually. So I found that your chart that shows the maintainers declining, I mean, it makes a lot of sense that the work kind of ramps up, and if it's part-time uncompensated work, that becomes kind of less attractive. People get worn down, and it's especially bad if they get hired away to some company. I wonder too if there's another problem, which is that you have a supply of maintainers that gets diminished, but maybe you have less of a pipeline for creating new maintainers. And I wonder what the problems are there, because it seems like the stakes get higher over time, so you become more and more concerned about the people you give that special role to.
Yeah, I think you're completely correct. Again, these inflection points all kind of happen at the worst time, like when it rains, it pours, right? Like right at the moment that you're realizing like, wow, we really need to like replenish maintainers, the job has gotten significantly harder, right? And so introducing and training up new managers, maintainers, leaders is a whole own set of work. And so I think that you're spot on in identifying that, and that this is just yet another one of what I would call like those operational costs that I think we too frequently overlook, particularly in open source. I mean, I would probably argue that I mean, even companies have this problem, right? I think when companies are scaling, they're suddenly like, oh shoot, like we need an onboarding program, don't we? Because like things have gotten complicated enough here that just having one person shadow you for a week is not enough, and maybe one person shadowing you for a week was never enough. Yeah, I think we're only just learning like what it really means to set people up for success, and that doing so is value well spent. Honestly, some of it I think is partially marketing, where like people do not readily understand the value of investing in those types of things, and it's up to folks who are the maintainers in these projects to come up with like how do we tell that story to motivate people to invest here.
Got it. Thank you. Okay, so Stephen Coe has a question, which is, what are some of the most pressing things that the Rust core team feels need to be addressed in the near future? The language, perhaps, the compiler, the organization? Any insights there?
Yeah, so as I kind of mentioned in the talk, the core team's kind of scope or its realm is really on the kind of like amplifying maintainers role. So while the core team, everybody on the core team has its own opinions about, you know, what might be pressing for the language or the compiler, like first and foremost, I think like continuing to strengthen our governance structure and our decision-making structure for the shape of the new environment we find ourselves in, I think is most important. As you can see in our 2021 roadmap, we're going down a chartering of teams process. And while that might seem potentially quite boring to some, like coming up with documentation for what teams do and kind of like what is expected of them and that organization is critical, both for like the sense of accomplishment and direction and focus of the people on those teams, but also helps people who are new to Rust navigate like where to find their own place in that structure. As I said, we have 10 top level teams, many of which have many sub teams and working groups. And I remember when I was first kind of navigating Rust governance structure in like 2016, and it was so much simpler then, and it was still pretty intimidating. So I think making those structures significantly more accessible and making the on-ramp easier is really the most important. Like I think there's a lot of people who are interested in doing the work that Rust desperately needs, but it's hard to connect people to that. And so I see that there. I mean, as far as like my own personal, if I was to like dive into the technical, I mean, the async await has always been a really important thing. I remember in 2018 sitting down with folks at the core team being like, for Rust to truly be a networking language, we need to have an example of spinning up a server that's like the node, like 5-line example. Like, how can we do that? And doing that in a memory safe language is actually, I think, both very ambitious, but really exciting. It's really difficult to do. The work that the Async Foundations working group right now, led by Nico and some other folks, particularly around generating user stories, that's like really the type of work that Rust wants to be doing, I think, and so I'm excited about that from both a process perspective and from just like a general product perspective.
Great, thank you. Several more questions have come in. So Patrice Godefroy asks, other than relying on voluntary monetary donations, how would you like to see the currently failing open source economy model evolve? Do you have concrete suggestions?
Yeah. So like, it's interesting, that word voluntary, I feel like is doing a lot of work, and I could probably have a huge back and forth about exactly what you mean by voluntary. But I think like the shape of what I'd like to see is something is kind of like what I had proposed, which is I think that maintaining open source software should become a career opportunity. And based on what I have at least seen in the tech industry, and I mean, barring some type of massive, potentially meteor strike level event that would like radically shake up how the economy of the tech industry works, nonprofit organizations are not going to be able to retain the talent that they would need to keep Rust feeling as successful as it does today in 5 years. And so what I'd really like to see is this kind of federation of companies leveraging open source in being able to tell the story about the value of having these open source teams, so that an open source project is a lot less like, like a community garden, and a little bit more like a research institute, like a multi-corporation research institute. Microsoft Research, despite Microsoft kind of being the owning there, like the program committee here is like a large federation of folks, and cooperation on that scale with the project remaining independent is what I would like to see, I think.
I'm realizing now that I think I didn't appreciate what you were saying in your talk. I'm going to try to say it back to you to see if you can confirm it to relate to this topic, which is that right now the open source approach is, like you say, these kind of folks who aren't paid or in their free time are maintaining something, but no one has invested. Even though companies may be using something, they haven't kind of invested in its success. And of course, if Rust as a language succeeds, then all the companies that use it succeed. And yet, if they don't invest in it to begin with, then there's no hope that it will continue to succeed. So like you said, this idea of voluntary, if you have this federation of corporations that are investing in it to begin with, they're guaranteeing its future success for their success. But then, of course, it's this, as you said, free to collaborate. The fact that it's a separate project in open source gives them the freedom to work on it together without all this crazy NDA and licensing and IP and everything else. It's quite clear from the beginning what's going on there. Am I on the mark?
Yeah, absolutely. And I think that's partially because, I mean, it would be silly for me to not mention that some of my frustration with the current economy and open source is due to like some direct issues I've had. So like one of the really classic ways open source gets funded, there's the whole microfinancing thing, which could be a whole nother talk. I'm not going to super address that. I'm not a fan. But it's grants. Grants are usually pretty classic. And grants are a huge inclusion problem, right? So grants start and end, right? But software lives for so long, right? So who's going to take care of this software that happened like because of a grant? Like you infuse something with resources, and then like right at that moment where you're like, how do we like operate this? How does this become a thing that can like last? You pull all the resources away. We see that with contracts too. And then the number of people who can go, yes, I can just sign up for a 6-month grant. That's fine for my life and like having to live. Like, I don't know, if you have kids, if you have like a chronic medical condition, if you live in the US and don't have health insurance, the number of people who can come to the table is just so much smaller. And ultimately, like, again, software lives for an incredibly long time. The idea that we can maintain that software with like spurts of money, it feels foolish to me.
Great, thank you. So Ben Zorn asks, are there lessons or best practices to learn from the Apache Software Foundation, or maybe anti-lessons? Can you compare and contrast?
So I guess what I'll say is I think a lot of organizations that have preceded us have done a lot of amazing things. I think one of the interesting things to say is a lot of those organizations were formed at kind of a particular moment in time, and that the shape of the kind of environment we're in now is somewhat different in shape. I think those organizations were potentially trying to solve different problems because those were the problems of the time. And now there's new ones. In the blog post that I wrote to announce the Russ Foundation, like one of the original problems with open source was like getting anyone to think it was okay to use it, right? I think a lot of organizations set that up like in a really, really great way. But now kind of, as I said, like we get to benefit from the success of those organizations. But now we have a new problem, right? So there's lots of orgs that I think are doing really cool things. The folks at Apache, I was gonna say there's a gentleman at AWS who is associated with Apache who has been helping to participate in some conversations about how we're setting up the foundation. He's been fantastic. I've spoken to so many folks at different foundations, notably this developer program. While this is kind of our own riff on it, I had pitched this to our lawyer initially, and he told me that I was like kind of crazy and that like you can't do that. But then did a little research and discovered the Eclipse Foundation actually has not exactly the same, but like a different developer program. And so I expect that like inventing things from first principles is not a very Rusty thing to do. We often talk about some of these ideas in Rust being new. Even in the language that I use in this presentation, we talk about it being new, but these are old, actually, ideas that have been around for a long time, just haven't been like brought into this kind of more industry programming realm. And so I think there are quite a few things to learn from all the different orgs. But again, I think it's really important, similar with like picking programming languages, right? Like know what problem you're trying to solve before evaluating the tool.
Great. And I want to interject. It was my phrase, anti-lessons, not Ben's, in case.
No, that's okay. It's a bit of a political answer.
And actually, there's a follow-up to Ben's question, which you just started to touch on, which is that foundations like Eclipse require member companies to pay less in terms of labor, for example, paying core committers to address the tragedy of the commons. This is sort of what you're talking about. But Marcus's opinion is that this concept maybe doesn't scale so well. Are there things, I don't know if you're familiar with what Eclipse does in detail, but I wonder if there are things you think could be done better.
So I guess I would avoid probably critiquing the Eclipse model directly, simply because I do not have the specific data. But I guess having a foundation pay developers, I think, is complicated. There's like a generation of foundations that paid core committers. And I think that made sense at the time, but given what we've seen with the ballooning of the tech industry, if it just simply from like a talent attraction and retention perspective, like the glory of being on a core team of an open source project, I think is, I don't know if it's losing its luster, but it's certainly changing. And I also think, like, if you were to look at Rust, for example, like who is the core committer? Like that concept doesn't even make sense in Rust. Like we don't call people committers. Most of our leaders, like maybe they're writing code, but that's certainly not the key thing they're doing. And we don't have a core team. We have like 150 people that we would count as that. So the scaling problem is something that we immediately run into. And so again, I think like instead of a monolith, we should have a distributed system. And the foundation's job is not to be the monolith, it is to be the coordinative cost of that distributive system.
Got it. Yep. Thank you. Let's see. So Saul Greenspan had a question, which is, have you or do you know of any studies of how long contributors stick around and the reasons that they stay or leave? And how often does the departure of an individual create a crisis?
Whew. So one of the things I am extremely excited about with the foundation, for our project directors, we have 2 representatives from the core team, but then we have 3 project areas with folks not from the core team who represent the project on the board, and one of those areas is collaboration. And the woman who is in that position, her name is Jane Lusby, and she and I have been riffing about all of the data analysis we want to do on our GitHub data, because there's a huge amount of that there. So the person asking, oh, could you try again? Siri's trying to get involved in the conversation. So the person who asked the question used the word contributor, but I think kind of classically I'm gonna like turn it to maintainer. We know, we don't have formal studies of this, but anecdotally, maintainers leave because they're burnt out, because the cost of coordinating all of the collaboration, which is like the massive amount of labor ask that's really done of a maintainer, particularly in the Rust project, it becomes too much. It's often because they were being paid potentially to do the work and that they no longer are, but there's other reasons around that. But like I would say overwhelmingly the people that like in a maintainer position that the Rust project has lost has been because of burnout. And those people leaving, causing crises, I don't want to be alarmist, but like it's been a heavy cost. I think even just like emotionally, just like these are people that we collaborate with really closely, and you know, they're valuable. We really care about our people at Rust, and when we think that like the system that has bore fruit due to our values could end up being harmful, I mean, that's something to really pay attention to. And it's at least I know personally something that motivates me tremendously. As far as contributors, I don't know. I usually think of contributors like a contributor can't leave because a contributor kind of like shows up and then they're done. And like it's not like a long-term commitment. So I would talk about maintainers leaving. We certainly have recurring contributors, and there's always a question of can we retain them and then convert them to a maintainer. But yeah, it's really about maintainers leaving, and yeah, I would say mostly burnout.
Got it. I wonder, this is me interjecting now. I wonder, you know, the way you described maintainers, it doesn't actually sound that fun. That you used to get to write code, and now you get to review other people's pull requests and tell them no, or tell them do this differently, or whatever. And I can imagine that shift in responsibility might be frustrating or difficult. I wonder if maybe you could elaborate on what a maintainer does beyond those things that I just said that might make the job seem more attractive, if indeed it is more attractive than that.
Right. Like, what's the balance, right? Like, is this just a bad job? I mean, I think I think it is a good question. And of course, there are people who thrive on that type of labor, and then there's people who are not. And there's always the question of, is the funnel towards that job, is that like a reasonable like ladder to like be like, oh, like you made a lot of really good pull requests, so would you like to not make pull requests anymore? Is kind of a bait and switch. The way I kind of think about it is a maintainer is, you know, an engineering manager to a certain extent. That's kind of like the job that we're talking about that is maybe not the most fun. But they also get to be product manager. They get to be product designer. In the Rust project, we do our RFCs. And so like you get to have the decision-making power about like where the future of your section of the project is going. And so that's kind of what I see as the trade-off. Like you're the person that people are seeking consensus from, like to decide if we're gonna like do this or not. And for that decision-making power, the balance is taking on the operation costs of the implementation. Of course, many team members also, like, particularly in some of the smaller areas, I would say, like, for example, in our dev tools teams, they're both. right? Like they're making the pull requests, and they're the ones reviewing and merging them. So and it can grow from there. But I would say the like powerful kind of side, the positive, you know, carrot to the stick of maybe some of this other work is the decision making power that's delegated to you. Okay. And I guess, but before we go too far, like doing code review and, you know, enabling contributors is actually, like, I would argue it can be an amazing experience, and not just kind of like sad, maybe code janitor work. It only becomes that when you're asked to do it and you aren't given enough support or resources. And so I think we all kind of look at that work and go, oh God. And it's because the default is that you are like just unfairly like asked to do more work than you ever possibly could. And so I think the work itself gets a bad rap just because we all kind of default to believing that you won't have the support and resources you need. I wonder if we can change that if the support and the resources change. And like the assumptions about like what have to happen and what conditions they happen under change.
Makes sense. Okay, there's a question from Mike Walker. He says, first, I want to thank you for your really engaging talk. A few of your slides touched on Russ' origin story with Servo. How important do you believe it was for Russ' origins to be co-developed with the project to solve a problem critical to the company, browser memory safety? Is there a crucible effect? Are there lessons for future language development here?
Got it. I'll be completely frank. Maybe there's like a blind spot in my personal history. I don't know what crucible effect refers to. Clearly refers to something that is supposed to be like a shared understanding that I don't have. But if I use context clues, like there is nothing about like Rust today that and Rust success today that it is not like, I'd say, like directly related to its history and how it was developed. So the fact that it was a very practical, like, hey, like Rust is not an art project, which is a totally reasonable way to create a programming language, but like a programming language designed to be an art project and a programming language designed to like solve a really specific problem are going to end up having different applications. And I think that in particular, with the problems that the folks with Servo were trying to solve, and it's complicated whether it's just Servo or don't need to expose org charts or anything there, but we'll use this Servo as the identifier. Like that. It was also lucky that that was a problem that like a lot of people were having. Like it didn't matter at the time that was a problem that a lot of people were having. Like they just like, we have this problem, we need to solve it. But the fact that it was a pain point that a lot of folks were dealing with, I do think was incredibly important. And I think that there's kind of a question here about like, are there lessons here for future language development? Is absolutely. And so also when I talk about this kind of like federation of companies that I want to invest in open source teams, I think one of the stories that companies should tell when they think about these open source teams is that these open source teams are like really valuable resources to product teams inside the company. And those product teams inside the company are also incredibly valuable resources to the project. So instead of like, you can think of what we're trying to do with the Rust Foundation as kind of like a recursive expansion of what was happening at Mozilla, right? So Mozilla had a Rust open source team, and it also had the folks working on Firefox and working on Servo. And those teams worked super closely together, and Rust benefited from that, Servo benefited from that. As we look to create this federation of companies supporting Rust, these product open source team pairs, I think are going to really help ground the language in solving real problems. There's always the pull towards theoretical purity. And I like using the statement. I don't know how many people here have read the HTML5 spec, not the most recent version, but the version before that. There's a section on priority of constituencies and talks about preferring certain constituencies over, and theoretical purity is the last one, and the first one is end users. I think it's incredibly important that we keep that focused, and half of that is just making sure that that communication pathway is, you know, impossible to miss. Like, it does not require intention to go seek out that communication pathway. It is a default.
Okay, I think we're winding down. Thanks for all the energy you're putting into answering these questions.
I was not lying when I said I really love questions. It would have broken my heart, honestly, if there were no questions. So I'm like, really, like, thank you for asking questions.
So Mike Walker followed up. He says, my fault on language. Crucible effect means forged in the fire of a hard problem or engineering quest. The quality of the output directly tied to the pressure of the application.
Yeah, I definitely think that helps.
Okay, and let's see. This somewhat relates to what you were finishing up there on another question from Penn Zorn about open source teams. You know, the DS3, just to provide some context for his question, like you said at the beginning, we're interested in developing ways, processes, languages, et cetera, to develop more secure systems. And, you know, we're worried about nation state level cyber attacks infiltrating our infrastructure through insecure systems. So given nation state level attacks, are there complementary approaches to preventing malicious open source attacks to malicious attacks on open source beyond better compensating maintainers? Are there, you identified that as a, you know, as a particular issue, and I'm certainly persuaded of that. Are there complementary approaches as well?
Yeah, absolutely. I mean, I definitely think, like, the center question of the people producing the software, if you create a lack in those people, that is going to leak, that the system will leak. If you are necessarily causing that lack in those people, no amount of, you know, services or resources on top, I think, is going to solve that. Like, if it's between, like, being able to buy groceries or, like, you know, handing my project over to somebody, like, you don't want people to be asking those questions, and you need to fully understand that people are having to ask those questions. It's wild. So I do think that there are other things, though. Like, one, I mean, certainly is that, like, I think we should start thinking about open source projects as institutions. As companies. And so the same way, like, that you have training and security and services and mechanisms for a company, I think that those also, like, need to exist from an open source project perspective. I think one of the things that I've seen in open source that is kind of weird to me is that a lot of the open source security solutions that I have seen out there tend to be external to the process of producing the software. And what I would say there is that, like, if I were to describe how that scales with O notation, like, it's not the scale curve that you want. Like, that's not going to work. And so I think the most successful interventions are going to be at the production level. And so that means working with maintainers, particularly. I think one of the most unsung teams in open source projects are the release teams. The things that release teams are doing are huge. Like, if I was talking about, like, where power resides in the Rust project today, like, obviously the language team has lots of power, compiler team, kind of classically, but the release team, there's a lot going on there. And so I think getting to know how the software you use is produced and looking to infuse that production line with resources and support, I think, is really important. And so, again, I see a lot of people investing in kind of these like satellite, like, okay, we'll, like, scan all your stuff. And I'm like, okay, but, like, that's that's not going to catch nearly as much, and it's not going to scale nearly as well as intervening on the production level.
Okay, I think we're at the end. Thank you so much for your talk and your candid and thoughtful answers to all those questions. That I don't know if that was a record for DS3, but I think it was close. 40 minutes, 40 minutes of questions to 50 minutes of talk. So well done.
Yay! I'm so glad. I appreciate it. Also, if you happen to really love Rust and want to get involved in the foundation or like these ideas, please reach out. My email, I don't know if my email address is still shared on the screen or not. Reach out on Twitter. We want people who are excited about these ideas, and getting other people excited about these ideas is super important. So come participate.
All right. Thank you again.
All right. Thanks.